We're going to do some review lessons 2.5, 2.6, IN5, and IN6. So on page 129, it talks about lesson 2.5. Lesson 2.5 is on graphing proportional relationships. So over to the side here, there's a quick review for us. So graph of a proportional relationship. So if it's proportional, it's a straight line through the origin. And you can identify the constant of proportionality k from the point 1k, or by dividing y divided by x for any point except the origin. So y divided by x, that's how we got our k values, if you remember. So k is equal to y divided by x. Or like they said, we could get them from the point 1k. That's our unit rate point, if it's 1 something, because what happens when you divide the y divided by the x, if you do k divided by 1, you get k. So whatever that y value is, if it's 1 something, whatever the something is, that's your k value. So for example here, is the number of sunny days proportional to the number of rainy days? If so, find the constant of proportionality and explain its meaning. So if you look at this, just from the graph, we can already look at this and tell it's a straight line. It goes through 0, 0, so it is proportional. It's just the question about what the constant of proportionality is. So they just looked at one of the points there. They looked at 3, 6, and they said, okay, x, y. Let's do y divided by x. So 6 divided by 3 is 2 over 1, or 2. So their constant of proportionality is 2. What I would recommend, if you have time, it doesn't take that much time to do that, so I would recommend trying it with another point and making sure you get the same thing. So if we do that, y divided by x, 4 divided by 2 is also 2. So that's kind of a confirmation that we've got the right number there. And so constant proportionality is 2. What does that mean? Well, we did y divided by x. So y is sunny days, x is rainy days. That tells us we have 2 sunny days per rainy day. So for every 2 sunny days, there's 1 rainy day on average. And this is not necessarily the case. It's maybe just for an example for us to look at. So if we look at the practice, number 1, does the graph show a proportional relationship, and explain? And so this one, if you look at the graph, what we're looking for is if we have a straight line and it's going through 0, 0. We do have a straight line on this one. The issue is it's not going through 0, 0, so this would not be proportional. So we could say something like, no, the graph does not pass through the origin. So if you look at number 2, they want us to sketch a graph that represents a proportional relationship. And there's lots of ways we could do that. Basically, we're just looking for a straight line that goes through 0, 0. If it's a real-life problem, we might be in this first quadrant. Sometimes we don't have to be, though. So like if we extended this somehow, the graph was extended this direction. As long as it's a straight line through 0, 0, that would be a proportional relationship. Lesson 2.6 is on applying proportional reasoning to solve problems. So if we look at the example over here, Anne-Marie makes gift baskets that each contain 3 pounds of gourmet cheese with every 2 boxes of crackers. So she ordered 80 pounds of cheese and 50 boxes of crackers. How can she adjust her order to make 25 gift baskets, each with no leftover items? So if you remember, we did one of these with flowers, I think, bouquet. So 25, we have a ratio of 3 to 2. 25 of each of those would be 75 over 50. So 75 pounds of cheese for 50 boxes of crackers. We have 80 pounds of cheese and 50 boxes of crackers. So what we would need to do, we have 80, we need just 75. So just order 5 fewer pounds of cheese, and that would do the job. So if you look at the practice question, decide which problems can be solved by using proportional reasoning and select all that apply. So the first one, Yanni buys 4 dozen flyers for $7.25. What is the cost of 12 dozen? So that one we could use proportional reasoning. There's no other information that they're giving us to believe that it's not just like a set amount for every dozen flyers, like a discount for buying more flyers, bulk discount they call it sometimes. So we could use proportional reasoning, and basically we have 3 times as many flyers, we're going to assume it costs 3 times as much. The next one, first class letters cost 49 cents for the first ounce and 22 cents for each additional ounce. What is the cost of a 5-ounce letter? So this one, since there's a different price based off how many ounces, that one would not be proportional reasoning. It doesn't mean we can't figure it out. We could figure it out. It's 22 cents for each additional ounce. So, well, we've got 4 additional ounces. That's 88 cents. 88 cents plus 49 cents. And then that would be our total. Okay, so we could still figure it out. It's just not, we're not using a proportion. It's not, 5 times as much for 5 ounces as 1 ounce. So that's why we're going to not check that box. The third one, they're giving us a table here, and then they're saying what is the value of y when x equals 8. Okay, now again, not to say that we can't solve it, but would we use proportional reasoning to solve this one? So with this one, they gave me y's and x's. So to see if it's proportional, we can take y divided by x. So 3 divided by 1 is 3. What should happen if it's proportional? These should all come out the same. The next one, 4 divided by 2 is 2. Well, that's not the same as 3, so I'm done. I know it's not proportional. Okay, and again, we could figure out what the value is. It's just we wouldn't be using proportional reasoning to find it. Okay, and then the last one. So same idea on this one. We could do our y divided by x. So 4.5 divided by 1.5 is 3. 9 divided by 3 is 3. And what happens is when we divide these out, we divide out each of these, they all are going to be equal to 3. So that one is proportional. So we'll check that box also. So the first and the last ones are proportional, the other ones are not. So we're just going to look at a few problems here from lesson IN 5. Some of these we might have already looked at, but just kind of refreshing our memory on this. IN 5, we were talking about some things with rate of change and slope. So if you look at number 2, what's different on this problem that we hadn't seen previously? This is not proportional. It doesn't go through 0, 0. So what we did is we can't just do y divided by x. We did change in y divided by change in x. So we're looking at these two numbers and we're seeing basically how do we get from one point to the other here. So change in y, I like to take the bigger number minus the smaller one. Probably a good idea to go ahead and mark your x's and your y's here so you don't get confused. So the bigger y value we have here is 1. to find the change in something, you subtract. So we could do 1 minus -5. And if we start with the 1 for our y, we have to be consistent. We have to start with the x from the same point. So that means we have to do 2 minus -1. Now we have to be careful here with these signs. Noticing all these subtraction signs in the middle, remember, we can add the opposite or change the sign, draw a line, whichever one you like there. And when we work that out, we'll come up with 6 divided by 3, and 6 divided by 3 is 2. So the slope of this line is 2. What's it mean if the slope's 2? Well, 2 is the same as 2 over 1. So change in y over change in x is 2 over 1, which means their graph, they're going by 2's here, so it's hard for me maybe to show this to you guys. But basically, to go from one point to another, we could go up 2 and over 1 to get to another point on the line. Up 2 over 1, up 2 over 1. Okay, and again, just that they're going by 2's makes it where it's not going by the squares necessarily on that one. Number 3, same idea, only this one they just gave us some points and asked us to find the slope of this. So if you wanted to, you could use graph paper and graph these out. Otherwise, you could just label them and start working it out. So we could do for this one, our biggest y value is 10. So change in y, subtract our y's, we could do 10 minus 6. For the x's, we could do 0 minus 24. 10 minus 6 we know is 4. If you get on autopilot mode and you add the opposite there, you'll get the same thing. In the denominator, if you want to add the opposite or change the sign, draw a line, that'll be negative 24. We know a positive divided by a negative is a negative. And then really all we can do otherwise on this is reduce that down. The numerator is less than the denominator. If we ignore the negative sign, 4 is less than 24. So we can reduce it down to negative 1/6. Don't try to make this to negative 6. Okay? The numerator is less than the denominator, so we're just going to leave it as a fraction, negative 1/6. Number 7 says we use a garden hose to fill a circular wading pool 39.6 centimeters deep. We measure the pool every 2 minutes. And the question is, what is the slope of the line that represents the change in the depth of the water? This time it's like these are all like ordered pairs. That's like 0, 0, 2, 4.4, and so on. Okay? So really they've given us more than we need. We really only need 2 points to find the slope of the line. So we get to just pick out whichever ones we want. So if you want, we could do 0, 0. If you want to avoid decimals, we could do 10, 22. If you want to do something else, that's fine. And so change in y, change in x, we could do 22 minus 0 and 10 minus 0. And so that'd be 22 divided by 10. Divided by 10 just moves your decimal one spot to the left. So that's 2 and 2/10. Or you could make it 2 and 1/5 if you did a mixed number. And then the part B says, what does the slope mean? Just look at your units there. So we did y divided by x. Y was the depth of the water in centimeters. X was the time in minutes. So y divided by x would be doing centimeters per minute. So we could say that the depth of the water increases by 2.2 centimeters per minute. And then part C, how many minutes will it take to fill the pool? The pool was 39.6 centimeters. So if you do 39.6 divided by 2.2, we can see that would take 18 minutes to fill. So number 9, Donald graphs the distance he walks over time. The graph passes through the points 312 and 416. So part A, they want us to find the slope of the line that passes through these points. I'm not going to necessarily be working over here too much, but we've talked about before, I don't like the triangles being underneath. It should be a up and over, not a over and then up. So change in y over change in x, if we look at these points. So for the change in y, if we want to make it easier, we might want to do 16 minus 12. So then the x's, we have to go in the same order. So since we start with the 16 for the y, we have to start with the 4 for the x. So it would be 4 minus 3. So this would be 4 over 1, which is the same as 4. So our slope is 4. And again, this one, they're going by 2's again, but you know, we could mention go up 4 and over 1 to get to another point on the graph. Just a side note here, we talked about also was that we know by the direction what kind of slope we have. So remember, this direction is a negative slope. We can make an N for negative out of that, and creatively we could make a P out of that for a positive slope. So this one definitely has a positive slope. We got a positive answer, so that's good at least. And then this last part, they want to know if we did the slope between 1, 4, and 3, 12, whether we would get the same answer or not. So same idea. We could do 12 minus 4 over 3 minus 1 would be 8 divided by 2. And that is 4, so we would say yes, the slopes are both 4. Okay, so what they're trying to get at there is that the slope is the same no matter what 2 points we pick. If we go up 4 and over 1, or if we go up 8 and over 2, well, you go up 4 over 1 and then up 4 and over 1 again. Altogether, you went up 8 and over 2, didn't you? So IN6 we talked about was linear equations, y equals mx. So that's where we found an equation of a line based off of the slope. All these are proportional. And so if we look at number 1 here, a graph shows the number of possible passengers for a given number of roller coaster cars that leave the platform. Use 2 sets of coordinates to write an equation that describes the relationship. So if you look what they did there, I see a 24 for a y value and I see a 2 for an x value. So that kind of tells me what's going on here. 24 for the y value would be this point, which is 324, and a 2 for the x value would be this point here, which is 216. Normally we wouldn't have to just use those 2 points, but you know, if this is already kind of set for us here, we'll just go ahead and go with it, I guess. So finding the slope, m is, instead of slope, we can use the letter m to represent that. So if you look at this, for our change in y's, so we could do 24 minus 16 for the y's, and for the x's, change in x, we could do 3 minus 2. So if we subtract that, we'll get 8 over 1, which is the same as 8. So our equation would be y equals 8x. Remember, it's y equals mx. M is your slope. So once you find the slope, you just put it in front of x, and that's your equation at this point. And then part B, interpret the equation in words. We could say each roller coaster holds, and that would be 8 passengers. Okay, if you look at your values here of x and y. This was passengers and cars, so that was 8 passengers per car is what we found for our slope. So number 2 is kind of similar to that. If we look at number 3, they want us to graph this equation y equals 2/3 x. So if we go to graph this, look at that equation, and you might notice it's in that y equals mx form or y equals kx form. So since it's in that format, we know it's proportional. If we know it's proportional, we know it goes through 0, 0, and it makes a straight line. So automatically, just by that equation, I can put a point here at 0, 0. Obviously, 0, 0 and it being a straight line isn't enough for me to know what the angle of that line is. So we've got a couple of options here. One option is we can make a table. If you want to do a column in the middle to work this out, kind of, you can. So 0, if I put in a 0 for x, 2/3 times 0 is 0. That one we already knew, 0, 0. So now I'd like to find something else. Just kind of thinking about it, if we put a 1 in for x, 2/3 times 1 would be 2/3. I really am not a big fan of graphing the point 1 2/3 because it's kind of in between. It's hard for me to see exactly where that is. So some of these, since we have a fraction, aren't going to come out very nice. So strategically, 1's not going to work very good, 2's not going to work very good. If I put a 3 in for x, that'll work out nicer. That'd be 2/3 times 3. Remember, 3 is like 3/1. So if we multiply, that'd be 6/3. 6 divided by 3 is 2. So that would be the point 32. Technically, that's enough for me to make my line, but I like to have a third point just to make sure this is going the right direction. So picking some other points, 4 is not going to work good, 5 is not going to work good, 6 is going to work good. So 2/3 times 6, that'd be 12 divided by 3, which is 4. So 6, 4, hopefully that lines up with my other points here, and it does. So we can draw a straight line through those points. The way to remember this, normally if there's not a fraction, normally I would just pick 0, 1, and 2 for my x values. Since there's a fraction, what I would do is look at your denominator. And I would use your denominator as one of the points, one of your x values, and then the next multiple of that denominator. So our denominator is 3. Next multiple of 3 is 6. So I'm going to use a 3 and a 6 as my other two values. The other option you have, I don't know if we talked about this a whole lot, is we could look at the slope. We know it goes through 0, 0. Slope is change in y over change in x. So if my slope is 2/3, what that means is I could go from a point on the line and I could have a change of y. So I could go change of y of 2. So I could go up 2 and I could go over 3, and that gets me to another point on the line. And to double check that, again, you could find a third point if you want, up 2 over 3. That one, it's a little more freehand. We got to kind of make sure we're careful about what we're doing. If you work these out by hand and find your points, that's probably more of a sure thing that you're getting the right points than just saying, I'm going to go up and over, and get some points and draw my line. But either one of those would be ways that we could graph that line. If we look at number 6, they want us to graph the line using the point -2, 6 and a slope of -3. So -2, 6, I can graph that point easily enough. And we want a slope of -3. So slope of -3, we could put that over 1. So that's -3 over 1. What we could do then, we could use, similar to what we talked about on that last problem, we could use that slope to find another point. Change in y is -3. So we could go from that point, we could go down 3. Now, let's check here. Okay, it looks like they're going by ones this time, right? So I can actually go down 3 boxes this time. Always check the scale they're using. So change of x of 1 would go to the right one. Positive is to the right, negative is to the left, just like your x-axis. And we can put a dot there, and then we could draw a line between those. If you wanted to, you could get one more point, go down 3 and over 1, and that actually would take you to 0, 0. The nice thing about doing it twice is that gives you 3 points to line up with each other. Might make it a little easier to make sure that our line's going the same direction it's supposed to. Notice the negative slope we have, and if we drew that, we did have a negative slope, N for negative. If we look at the assessment practice number 8, graph shows a proportional relationship between the temperature in degrees Celsius and the time in minutes during a science experiment. Write an equation to describe the relationship. So if you look at this, first of all, we can see it as proportional. Goes through 0, 0, and it's a straight line. And then what we could do is just find another point on this line. So with the numbers they give me, maybe you see 2, -12 as a point. So from that, we could do change in y over change in x. We could find our slope. This time I'm going to do a little different. I like to subtract 0 from stuff. So we could do -12 minus 0, which would be -12. 2 minus 0 would be 2. -12 divided by 2 is -6. So my slope is -6. It's proportional, so it's going to look like y equals kx or y equals mx. So that means my equation is going to be y equals -6x. Interpret the equation. So we could say that the temperature decreases 6 degrees Celsius per minute. Number 9, bus X travels 224 miles in 4 hours. Write an equation of the line that describes the relationship between the distance y and the time x. So we're going to be trying to find how many miles per hour. So 224 miles divided by 4 hours. We're going to assume that this is just proportional because they don't tell us any other information. And so if you divide this out, that would be 56. So that means 56 miles per hour. And actually they told us distance y and time x. So our equation is like y equals mx or y equals kx. And so our equation is going to be y equals 56x. So this gives you an idea of what we're looking at in lessons 2, 5, 2, 6, IN5, and IN6.